Hello, everybody, and welcome to today's webinar presentation, A Microservices Movement, Tracing the Effects of Microservices on Java Development, brought to you by Perforce. I would like to introduce to you our presenters. First, we have Curtis Johnson. Curtis is a production manager at Perforce Software. Curtis helps Java development items leverage tools to iterate faster, accelerate time to market, and improve customer experience. Second, we have Rod Cope. Rod is the CTO of Perforce Software. He provides technical vision and architectural leadership for the company's global distributed development teams. Based on his analysis and market events and trends, he also influences product direction and messaging. I'd like to do a quick sound check for both Curtis and Rod. If you could say hello to our audience, and audience, please let me know if you can hear them both.
Hello, everybody. This is Curtis. Glad to have you guys here today.
And hi, this is Rod. I'll talk to you after Curtis.
Awesome. I can hear you both, and it seems that the audience can hear you as well. So with that, we will go ahead and get started. Curtis, I'm going to share the rights over to you.
Excellent. Thank you guys so much. I appreciate it and looking forward to talking to you guys for the next little bit here. Yeah, so we're just going to jump right into this. I'm not even going to talk about myself because she did such a great job talking about me. I don't feel like I have to add anything else to it. But yeah, I have been working here within the Perforce company, specifically in the JRebel products, for a very long period of time. So I've loved being able to be participating in this report over the last several years. But it's a great being able to pull this back up and doing this again, and getting the opportunity to discuss a lot of the findings today from our report that we did, and some of the feedback that we got from some of the clients and customers, which we're going to show a little bit of today, show some of the technologies people are using, and discussing how we're going to be able to move forward in a microservice focused world. A lot of the questions actually led to some interesting findings around microservices, and so we're going to be discussing some of those as well. So first off, let's talk a little bit about the overview of this report. Now, this report was asked over 400 Java developers throughout the world. We focused mainly on developers. You can see that there are some other team leads and architects and even some C-level people, but for the most part, we targeted developers. And the reason is because JRebel is a developer-centric tool. XRebel as well. We are all focused, and we want to know and understand developers throughout the world. And this is one way that we believe can help us understand more what developers experience on a day-by-day basis. And so we got the opportunity to ask them questions about performance and about productivity and microservices that they're using and how they're building in their application. And then we got the great opportunity to really get an understanding of exactly where their strengths and weaknesses are, what things, how our tools are providing solutions, and how our solutions are working within the Java ecosystem as a whole. You'll find that a large number of the people that we talk to are in that nice, sweet range of 2 to 10 years. Over 60% of the developers we discussed, we interviewed for this, were in that 2 to 10 year period of time. We got some people that are going at that 10 plus years. They're the more experienced people, obviously. And then we even have a good amount of people that were coming in pretty new, didn't know the technology, might not know the technology so well, or even their environment so well, but they're learning on the process. You can also see that vast majority of the teams are in agile environments, because as you can see, we have team sizes ranging from 3 to 9 to 10 to 12, definitely more of an agile scenarios. I imagine that most teams are more in that realm than anything. The other major aspect is that we are talking to a lot of enterprise companies, as well as mid-sized companies. These tend to be where you see Java being most prolifically being used, as it provides the most benefit for that back end development. So a little bit into technology. We found some very interesting things. Some things we were kind of expecting, some things were a little bit surprising. The one interesting aspect, Java 8 is widely being used still. And even with us coming out with Java 14's coming out pretty soon, we're rolling through different versions of Java, and people aren't updating as much as you would expect. And I kind of expected this, to be honest with you. I think that there hasn't been any really major feature changes within the most recent couple long-term support releases, even with Java 11, which makes it less likely for people to want to put the resources necessary to adopt newer versions of Java, which I think will eventually, I assume people will start moving out of Java 8, but the resources that are required to make the changes don't equal out to the benefit that the newer versions of Java offer. And so I don't see any major changes happening anytime soon, but you never know. You never know how the environment might be changing as we go forward. One of the interesting aspects is you do see a large amount of people that are using Spring frameworks within their Java environments. This is pretty expected. If you've ever been to any kind of Java conference or talk to anyone that works in Java, Spring is #1 thing that's being talked about. I mean, every environment is using Spring in some form of the way. They'd be foolish if they weren't. And probably the most interesting thing the most interesting aspect in my mind is IntelliJ being almost unanimously used throughout the developer world at this point, or at least at this point, pretty strongly being used throughout the developer world. I think that this is interesting. I've been doing this for a while, and when I started working in Java community, for sure, Eclipse was way larger than this, but it's lost a lot of that foothold within the IDE world, mainly I think because IntelliJ is just more professionally made. It's easier and definitely provides a lot of really in-house solutions that really helps feed alongside those microservice environments using Docker. It's just so much easier to use so many different technologies within it. I think it's a no-brainer for it to be so popular. It's interesting also if you look down in the bottom right-hand corner where we discuss the JDKs that are being used. Oracle JDK, I expect to continue to be a large amount. I think that this also corresponds with that Java 8 usage, because as you move away from those older Java versions, I believe people will be moving more and more to the open source JDK distributions. And as you can see, OpenJDK is growing and will continue to grow as people transition into newer versions of Java. This will be happening. Almost everybody's using OpenJDK if they're not using the Oracle JDK. There are all kinds of different distributions that are out there, from Zulu and so on. But each of these provide, solutions within that OpenJDK environment, which I think is going to continue to grow as we move forward. Now, it's interesting because one of the things that you run into and we always experience, especially here in the JRebel world, is how long do people spend waiting for restarts of their application server? Development is obviously important to a developer. That's what they're doing. It's what their focus is on. It's what they are getting paid to do. You are paid to make and write development and write good code. And so the amount of time you are spending doing things that aren't enabling you to write and develop code is problematic. And so when it comes to productivity, you can see that most developers are spending about 2 to 3 minutes for each redeploy of their application. Now, this is considerable still, and this is where our JRebel product proves to be the most useful in eliminating this time that you are spending waiting for this application server to restart. So now we actually are going to do our first poll. Hand this over for the first poll question. Now the question is, how big of a problem is performance in your microservices application? This is including scalability, latency, throughput, and uptime. We have four main options you can do. We got pretty bad, it's a problem, don't like it. Worrying, it seems like it could be a problem, I don't know, it might be a problem in the near future, don't know, still assessing. Minimal means, obviously just not really there, or just don't really use microservices. So we would love to understand, obviously, where people are, especially here. Well, we want to know where you guys are experiencing performance issues, how performance is affecting your microservice environments that you guys are working in today. So as people are going, I'm just going to keep moving forward. I feel like that probably will be best. Now, when it comes to microservices, as people are filling these out, performance issues are always something that have to be addressed one way or the other. And it's interesting because sometimes you're addressing these issues right away. You're able to catch them right there as a developer team, identifying these performance issues. Sometimes you have to run some tests to identify the performance issues. Sometimes you have to wait until you get to a production scenario or even to a customer use case specifically in order to address those. But this is going to help identify exactly where those performances are occurring. So let's see. Oh, excellent. We got some results in. So it looks like the majority of people are worrying about that it will be a problem at some point, but not too bad at this point. So that's good to hear. It seems like at least at the point where you're able to address some level of the problems that are happening. And a couple people here are having it impacting their users, but most are not experiencing very extreme problems in this. So that is encouraging. And we have about 38 of you guys are not using microservices. So that's excellent to hear as well. So you guys can hear a little more on what we have as well when we talk about microservices as well. So going alongside with that poll goes into what we actually found as the results in our polls that we did. We found pretty similar information, but the interesting thing about what we actually saw is where the issues were coming from. First and foremost, you're going to see that there's obviously a large amount of these issues are coming from the actual application response time. Now, the most clear and present issue always appears to be in this, where developers, no matter what their team sizes are, how they're writing or developing their application, the amount of time it takes for an application to make its requests seems to have a pretty substantial impact on the performance of your application and how it's going to be able to work. And it tends to result in issues that you're going to be able to identify as quickly as possible and hopefully avoid getting those to experiencing for your development teams. Now, it is interesting that most requirements are being defined, or non-functional requirements. So it's about 50-50 on this. If you have non-functional requirements defined in your performance of your application. I feel as though this is something that more and more development teams are going to have in the future, but it's interesting to see that it's pretty much, you either have it or you don't. It's about a 50% chance here on this. Now, when it comes to when people are actually identifying performance issues, you can see a variety of results come from this. Developers are testing about 70% of these issues, which I think is encouraging to see. I think that the more developers are involved in these processes, the less that are going to end up on that bottom one where you have customers reporting it. obviously the bottom two actually, really, as both of those are production scenarios where you're going to be seeing immediate results affecting the end user. So and this is where you're going to be seeing a lot of the performance hits being occurring within the application and within these Java-based applications. And I think that this is really where you see a lot of that pan out. So what we're going to do now, we actually have our second poll question. And so this is an easy question. Is your company optimized for microservices? And this is pretty easy. Yes, maybe, no.
Curtis,
Yeah,
this is Rod. I can add a little color just for the people trying to figure out what that means. I think for yes here means you've got the right team structure. It's not just only technical, but team structure, executive sponsorship, a culture of Agile and DevOps, lots of automated testing, CI/CD, monitoring, self-healing, all the things that are required for a very smooth, streamlined microservices adventure, right, from development through test and production. And the somewhat would be, okay, maybe you have smaller teams in your Agile-ish. Maybe you have some DevOps, you're still kind of getting there, some automation, basic monitoring and analytics. So you've made some strides in a bunch of areas, but maybe you still feel like you have a ways to go. And then for no, I would say, if you've got large teams, you follow a waterfall process, maybe a little bit of, quote, Agile, that's maybe not truly Agile. You have development and QA not really integrated. Maybe some basic CI/CD Jenkins, but you still rely quite a bit on manual testing, things like that. I would say that's more, no, you're not optimized for microservices yet. So if that helps answer the question, I think that detail might help a little bit.
Yeah, absolutely. Thanks, Rod, for that. Pretty good mix of results here. I like this. So we got 23% at yes, 42 at somewhat, and 35 at no. Excellent.
Yeah, I think that's good that at least a good chunk of the people responding realize that they're not in an ideal situation yet, and that's good. In the right place to learn and do more. Absolutely.
And it goes right into this next slide, which is starting to get into our microservices discussion. But as you guys can see, in the top right here, we have a little bit of a breakdown of what is the status of microservices adoption. And you'll see that there's a large amount of people that are either fully in a microservice-based environment or at least discussing the use of a microservice environment. And I think that this will continue to develop and change as we go. It's interesting. I have a hard time believing 27% of them are using a fully microservice-based application, but I do find that this is a continual process. I think that this is something that you're going to see continually growing and fluctuating as we go, in that a lot of people are moving their applications, or at least parts of their applications, into a more microservice environment and methodology. You also could see that there is a continuous amount of monolith-based applications, which I think it will always be around. I think that there is some legitimate viability behind monolithic-based applications, and I don't think that they will be going away anytime soon. I think that as you can still see, obviously microservices are growing greatly, and I tend to see more often than not, when I talk to companies throughout the world, that they have aspects of their application that are microservices and aspects of their application that are monolith. And most of the time, if they have any microservices, they immediately will say, this is a microservice application. And I guess you can argue it, but it tends to be a mix of the two, more often than not, at least in my experience. With that, let's talk a little bit into what are some of the effects of microservices. So first off, let's talk a little bit about some of the microservice technologies that are out there. I think this is a good starting spot for us. Obviously, as you can imagine, Spring Boot, Docker, Tomcat. Clearly the main technologies being used within microservice-based applications, microservice environments. These questions actually, none of them are specifically about microservices, but they all brought out all the major use cases for microservices, with obviously Kubernetes coming in very strong here on the virtualization tool. Now, I know people are out there complaining to me about this having Kubernetes as a virtualization tool. I understand Kubernetes is more than just a virtualization tool, but how many people are using it as a virtualization tool is really more of what this question is digging into. You know, we all understand that there are many other features that Kubernetes also provides and offers beyond just that specific functionality. So yes, and it's also interesting seeing just how dominant Spring Boot is when it comes to our runtime platforms. I think that this will continue to be the main form of running our applications going forward, which lends to the strong Tomcat usage that you see on the application server section. I think that that's the lightweight application server like Tomcat is the way of the future, or the way that we're going to be moving forward. You know, which is why you're not going to ever see these larger application servers really get much higher anymore, I don't think. So yeah, absolutely. So with that, what I'll do is I'm going to hand it back to Rod, and he's going to talk a little bit about some of these challenges developers experience.
All right, thanks, Curtis. Yeah, I think this was one of the questions that struck me as pretty interesting, in particular with the overall survey, is, you know, what's the biggest challenge when you're developing microservices? Well, I think what's interesting here is that around 30+% of the respondents checked all the boxes. So there are a lot of challenges with microservices, and that's not too shocking, given that it's so different from what we've had in the past with, for example, monoliths. So let's take a look at each one of these challenges in particular. It starts with setting up the environment. So if you've got a lot of microservices, you know, if you've got 2 or 3, it's not a big deal. If you've got 200 or 300, then it's definitely a big deal just to get everything up and running on, for example, a developer laptop or some integration server, or even in a cloud that each individual developer can kind of have access to the whole application and can see how their particular microservice fits in and how it might affect performance and scalability and fault tolerance, etc. So getting that set up can take a lot of time as well, and we're going to talk a lot about automation and some other solutions to this in the next few slides, but we'll talk about the challenges for now. It's also challenging to troubleshoot when something goes wrong among these services. Right? If you think about just the context of a single microservice, not that bad, pretty straightforward, pretty small. But when you've got a lot of them and you're trying to troubleshoot some partial failure or some partial slowdown, occasional dropped messages, or some other kind of weird hiccup in a microservice that then ripples and affects others, that then ripples further and affects others in a complex graph of dependencies, that can be tricky to troubleshoot. You also have to deal with, for exactly the same reason in this distributed system, performance overall. How do you continue to scale? How do you deal with, for example, outages or just slowdowns in third-party services that you use? Because we see, especially with microservices apps, when you've got a complex architecture like this, you often rely on third-party APIs, typically in the public cloud, as part of your service. And so if you're waiting on an API call to respond, you're kind of adding their latency to yours. And if they have a hiccup or a timeout or some cascading failure, it can affect your microservice, which could affect your entire app. So that can be challenging to work around and kind of abstract and isolate yourself and buffer yourself from those problems that other dependencies experience. You've also got, we talked about cascading timeouts in performance issues, but also cascading failures, scaling mistakes, things that cause chunks of the system to go down, maybe because one service timed out, which triggered another one to time out, which made some other service think that service was completely down and failed over or something. These kind of ripples can be challenging because in a large enough system, you're always in a state of partial failure, right? If you've got hundreds of services, something is always down, something's always being scaled up, failing over, etc. And again, troubleshooting and tracing your way through that can be a bit of a mess. You've also got monitoring issues, scaling and monitoring. As you add more and more services, microservices, and containers, and individual ones are being scaled up and scaled down, how do I monitor and know, okay, it looks like this service is scaling up, which is going to increase the load on another service. How do I scale that up ahead of time, or do I wait until there's an issue that could affect production before I begin the ramp up? You don't want to have your end users suffer latency issues or timeouts or failures. You want to be proactive. So how do you do that across a complex set of microservices that could all be written in different languages, running on different platforms, using different tools? Finally, the other challenges here that survey respondents pointed out is just dealing with all the dependencies. It can be versions in your stack, different languages, different security issues, patches, upgrades in progress, etc. Do we use standard databases, or does every microservice choose its own relational or non-relational NoSQL database? Where do they store the data? Is it on a SAN? Is it in the cloud? Is it a Kubernetes stateful set, etc.? Those are a lot of different choices that could be made in one environment, but you have to manage it as a whole and think about the overall application in terms of visibility, monitoring, performance, and uptime. So a lot of challenges, and I thought that was a pretty interesting result that users are kind of seeing all of them. So on the next slide, we kind of look at what's happening today. And Curtis mentioned a number of these technologies, things like Docker and Kubernetes and deploying to the cloud. I think these are all pretty common for most people deploying, whether it's on-prem or in the cloud. You're probably going to use Docker, probably Kubernetes, Jenkins, or some other CI/CD tool to make it easier to automate and use DevOps practices to get things from development through integration to QA to staging environments to production. You don't want to do that stuff by hand. It's way too complex to deal with the networking and the scaling up and scaling down, etc. Using things like Prometheus and Dynatrace, Grafana to track and see what's going on. And again, we mentioned that a lot of these microservices can be written in different languages, different tools, different platforms. It can be challenging to have them communicate. And to do that right, you want to use asynchronous communication, things like message queues, things like Kafka. We're seeing take off kind of rapidly in these environments to isolate services from each other and let them be written in different languages. And then finally, using things like JRebel so that you have performance in place from the beginning and you maintain good performance as you change tools, languages, platforms, scale up, scale down. You don't want to introduce issues that are only found by end users in production. You want to find those upfront during development and keep your performance good. Okay, so that's all kind of current. Let's now look ahead. So here are some trends and predictions around kind of what's coming next. And so we'll start with global kind of trends that are happening now, and these are demands. We'll talk about some of the ways we address these demands on the next slide. But we'll look at what are some of these challenges hitting development teams now. And these are going to continue to increase a lot in the coming years. First of all, and I talk about this in lots of presentations kind of around the world, I talk a lot about future and future of software, future of technology, what's coming next. User experience is always top of my list. It's all about how do we have a better user experience, be more proactive, make it easy for users to get their data the way they want it on their device how they want it, when they want it, and it's got to be super fast. So all of these kind of user experience things are being driven by the consumer companies, think the Apples of the world, trying to make technology and computing seamless and as easy as possible, which means fun, friendly, fast for end users. Those are the kind of demands now being placed on enterprise developers and corporate software. You can't get away with only ugly, nasty UIs and slow apps for very much longer. People expect better. So that's a challenge. Another challenge is as these systems get more and more complex and there's more moving parts than ever, how do we have good visibility? How do we debug these partial failures that span maybe dozens of services, and it only happens in rare circumstances under special load? So that's going to become even more challenging over time as teams get larger and you get more and more microservices in the mix. All that's driving more storage, more need to access, and the need to go faster than ever. You know, analysts are saying that we'll see 10 times more change this decade than we saw the last decade. That's an enormous amount of change, which means getting your applications out faster with better quality is even more important than it was in the past. And all that data means higher demands on data security, privacy. You can't expose the data. You don't want it to be corrupted. You don't want it to be hacked. How do you deal with this avalanche of new services and data? And finally, one that keeps popping up is another challenge for the implementers of these systems is that engineers are human. We want them to know everything. They obviously can't know everything, but they're being pushed to know more and more than ever. We see more need for full stack developers, for people who can work on front end and back end and understand performance, security, reliability, distributed computing, and the list goes on and on. So how do we deal with those challenges? So these are a bunch of demands. So on this next slide, we'll talk about how do we solve some of these problems, or how do we make this a little easier to deal with. Well, one, on the user experience side, we're seeing more and more use of AI. This can be machine learning, performance tools, again, like an JRebel to make sure you have good performance throughout. I think AI is going to drive a lot of this because it helps you do things like proactively suggest things to the user to predict what they might want and to offer it up to them before they have to ask for it themselves. It can be things like in the development environment to let developers know, hey, if you add this field to your query, it's going to slow down your production database access time by 10 more milliseconds. It's going to be things like troubleshooting across all these microservices. So this is a developer type user experience, and that flows into the second bullet here. So as these systems get more complex, how can we use machine intelligence and things like augmented reality, virtual reality to let developers and operations people visualize all these moving parts and microservices and visualize the flow of traffic between them to see quickly where are the bottlenecks, where are the cascading failures, where are the correlations when something goes wrong. You know, you don't want to have individual developers pouring through log data, trying to match up one log of one microservice to dozens of other logs of other microservices all at the same time. You need tooling to help make that a lot easier. So distributed monitoring and tracing tools, you know, things like Zipkin and others that let you see across systems and more easily correlate interesting activity. On the more data storage and access side, I think we're going to see more and more use of things like GraphQL, which, if you haven't heard about it, I think of it as an easy way to ask for data exactly how you want it, even if it spans multiple services, microservices, APIs, databases, what have you, without having to know all the details. So on the client side, you can kind of just say, here's what I want in the format, the shape I want it, and let the backend deliver that to me. That's required for developers to go faster, to not have to get bogged down with some of the details, and to be able to access multiple sources of data and join them very easily. Things like backend as a service. We're seeing more of those pop up on the internet, where you can focus on, again, user experience, user UI, and let the backend kind of handle some of these transactional and complicated issues. You don't have to write it all from scratch. And then finally, these BFS, the backends for front ends, basically. So again, focus on user experience, focus on UI, and then custom implement backends to perfectly serve those UIs very quickly with high security, low latency. And then finally, with the engineers needing to know everything, I think it will be an ongoing challenge, because developers need to know enough about the big picture, even if they're working on a microservice, to know how their microservice fits into the whole. Otherwise, you're likely to see teams that focus solely on their own microservice, and it does a really good job, but the company goes out of business because nobody cared about how the pieces fit together. So you need to know enough of the big picture, back end, front end, a little bit about distributed computing to understand it, but then focus and specialize in one area. And if I had one recommendation, that would be focus on user experience. That's where we're all going to compete in the future. Everybody will have the same access to cloud. Everybody has access to the same open source and same tools. It's what do you do with it? How do you put it all together in the best possible manner for your users? That's who's going to win the race. So focus on UX, and then UI, AI can help you have that better user experience. Okay, let's turn now to looking toward specific microservice trends and predictions. I think the biggest trend that I see coming up is people are now realizing this is really hard. This is true distributed computing. With monoliths and simpler architectures, it was easy to say, hey, you've got one web server, one app server, one database, and yeah, we can cluster and scale those up, but everybody understands where the data is and how transaction works. Now you've got these complex eventual consistency and saga patterns and things you have to deal with big microservice implementations. It's extremely difficult. You have to automate and use DevOps and use automated testing, automated deployments of environments, automated monitoring, and self-healing as much as possible to have a chance. You can do some of this by hand if you've got a few or handful of services. If you've got hundreds, forget about it. It's got to be automated. You have to use tooling. And for these reasons, because it's complex, I think we're seeing more reversals. Companies that are deciding, at least for specific projects, that microservices maybe aren't a good fit. They're too challenging. Even some of the big analysts have said a lot of companies, up to 90%, will revert at some point and say that microservices are too difficult for certain apps and fall back to mini services or monoliths to relax some of those constraints. So it's not a panacea. For developers, I think we're going to continue to see full stack expectations. They'll have to understand DevOps. They'll have to automate. Automated continuous testing is absolutely mandatory, especially for performance, so that you have low latency and good throughput at all levels of scale required for the app, and you don't break it and rely on users to report issues, right? You have to fix those problems in development and QA. Don't let them bleed into user experience. So final thoughts. I don't think microservices are one size fits all. I think use the best tool for the job. For example, if you've got a short timeline and a team that's new to microservices, don't go that route, or it's a recipe for disaster. I think you'd be better off in that case doing a traditional architecture, monolith or what have you, proving business value, making sure it works, get the funding, and then slowly transform that to microservices, maybe using something like a strangler pattern. And we've done other webinars you can look up for that. But don't do microservices just because they look good on a resume. They're going to fail frequently. So use the best tool for the job. So if the best tool is microservices, and you like the flexibility they give you and the ability to make parallel progress on lots of small applications instead of one big one that can cause bottlenecks, then use service meshes. Use things like Istio, so you get consistent security, networking management, configuration, metrics, monitoring, etc., and you're not reinventing those wheels for every microservice. Still use things like Akana for API management in front, but if you're going to go microservices, I highly recommend a service mesh. And finally, if you want to go serverless, a lot of companies are going this way because they like not having to deal with containers or Kubernetes or anything. They just want to run code like a cloud functions, Lambda functions from Amazon, Microsoft, Google, IBM, what have you. You can go that route, but be very careful of the impact it has on performance. Latency, cold start issues, monitoring can also be a challenge when kind of in the big picture where you have a mix of microservices that are maybe on-prem or in multiple clouds and then some serverless. Really think hard about performance and make sure you measure that consistently. Don't wait to the end and hope for the best. Okay, and I think with all of that, if we have time, I think we'll move on and see if we have any questions.
Awesome. So I will go ahead and ask you, Rod, some questions first, and then I can go ahead and ask Curtis. So first off, Rod, if microservices are so hard, why is everybody going that way?
Yeah, that's a good question. It is the trend. I think it's a very hot topic. Everybody wants to talk about the benefits of microservices, and there certainly are some. And so although they're challenging, a few of the main reasons people move to microservices are that they can have the flexibility and freedom to choose different technologies per service. So for example, maybe Spring Boot in Java is exactly the right stack for a particular microservice for one team, but you have another team that wants to do a microservice. Maybe they're from another company you've acquired. Maybe they're in a different geography, different skill set, different tooling. They want to use Node.js, for example. You have another team that's very well versed in Python that focuses on AI, maybe. Microservices let you do that. With a monolith, you couldn't choose 3 different stacks and 3 different languages. With monoliths or with microservices, you can choose different stacks. You can evolve more frequently. You can try things like with Java with Micronaut or the Graal VM, or use different versions of the JDK across teams. Use different versions of Spring or other tools. You get a lot of flexibility there, and you can deal with small problems solved in parallel, leading to smaller teams and smaller solutions than you get with a monolith. So there are lots of good reasons that people go to microservices, and I think those are some of them.
Awesome. Thanks for answering that question, Rod. Your second question is, what are the most important things to do when moving to microservices?
Well, I think some of the important things are what we talked about today. Don't forget that this is distributed computing, which is hard. So don't skimp on things like performance testing all along to make sure you're not building up latency and affecting users when you go live. Make sure you have lots of DevOps and automation and the appropriate tools in testing for all that. CI, CD pipelines, things like Kubernetes and Docker, right? You want to eliminate as much of the overhead of manual system administration as possible. Automate that because it's too time consuming to do by hand and way too error prone. So those are the key things like automation, performance, security, testing. Those are, don't skip any of those areas. I think are absolutely critical.
Great, such great answers, Rod, and thank you for answering both of those questions. Okay, now we'll move over to Curtis. So Curtis, why do you think that Java 8 has such a big hold on the market?
Yeah, I think that Java 8 is just the thing right now. I feel like there's a lot of reasons that people are staying at Java 8 and not transitioning into newer versions. I think that as newer applications start to become available, you will see a growth in newer versions of Java 8. I also think that Oracle will force a number of companies, especially some of these larger companies that, or maybe really more of the mid-sized companies that are being forced into paying for Oracle JDK. They're being forced out of the Oracle JDK environment and then moving into an open source solution using OpenJDK type solutions. And I think that will result in a lot of these mid-sized companies and maybe even some of the large companies moving away from that Java 8, moving into Java 11, potentially even Java 14, which will be the next long-term support solution out for Java. And I think that those types of things are what's keeping people from wanting to do it. But at the core of that question, I think the reason really is that there hasn't been any huge updates to Java, no catastrophic, at least, updates that make it like you need to update to the newest version of Java. In the past, I feel like there was a lot longer period of time in between releases, which resulted in a lot more content being made available in those Java releases. With less content, I just think development teams and architects are deciding not to spend the resources necessary to update to newer versions of Java.
Great. Thanks so much, Curtis, for that information on Java 8 and the market. So it looks like our audience doesn't have any other questions. So with that, I would like to thank Rod and Curtis, both of you, for such great presentations. I would also like to thank Perforce Software for providing the audience with such a great webinar. Lastly, thank you to everyone who attended today. We hope that you learned something new and hope that what you learned today will help you in your developer career. Again, just a reminder, this webinar is recorded. You will receive a follow-up email with the recording, and we hope you have a great rest of your day.
Thank you, everybody.
Thanks. Have a nice day.